Okay, so we're looking at 2019 number 3. So if you would take an opportunity to read through the problem and prepare to look at it with me. So I'm going to start off by just looking at the directions. It says a continuous function f is defined on the closed interval from -6 to 5. And this shows a portion of the graph starting at -2 and going to 5. And for part A, we want to find the integral from -6 to -2 of f of x dx. And we know the area under the curve is equal to the integral. So we are looking for that area under the curve. So I'm going to advance to the next screen, which I have a very bad drawing ready for us to look at on that next screen. So we'll advance to that at the pieces of the area under the curve. So the first area under the curve I'm going to talk about is right here, this triangle, and the area triangle is 1/2 base times height. So the integral from -2 to -1 of f of x dx is going to be 1/2 the area of that triangle. Then the second thing I'm going to look at is going to be the loop portion, and so that is going to be the area of the triangle of another triangle. And now I'm going from -1 to 0 of f of x dx, and that 1/2 base times height, but because it's below the x-axis, I have -1/2. Then I'm to look at the green portion, and the green portion is also below the x-axis, so I'm predicting negative integral. So I'm going 0 to 1/2 of f of x dx, which is -1/2. And then moving on to the next portion, which is also a triangle. And now we've moved above. So now we have integral from 1/2 to 2 of f of x dx. And that is going to be 9/4, 1/2 base times height again. And now we have the orange piece. And the orange piece is going to be part of that semicircle. Now, we know that the radius of the circle is 3. So I'm looking specifically at the integral from 2 to 5 of f of x dx. And what I'm going to do is I'm going to take the area of that rectangle, which is 9/3 by 3. So again, referring to the whole rectangle here. And then I'm going to subtract out a piece of semicircle, which is pi r squared, which is going to be 9/4 pi. And that is going to be the semicircle. Again, the area of the whole circle is 9 pi. And then because I have 1/4 of it. So the remaining area, the shaded in orange there, is going to be the rectangle minus the semicircle. So that's how I get that value. So now, if I want to go and find the area from -6 to -2, I'm going to say that the area from -6 to -5 is 7. That was given to me in the original problem. So I now have 7 for the area. That's going to be the integral from -6 to 5 of f of x dx. And I'm going to say that is equal to the integral from -6 to -2 of f of x dx plus the integral from -2 to 5 of f of x dx. So I can then say that I have the integral from -6 to -2 of f of x dx equals 7 minus the summation of the areas going from -2 to 5. So I have 7, and then I would have minus 2 minus 9 plus 9 pi over 4, which ends up being -4 plus 9 over 4 pi. So the integral from -6 to -2 is going to be -4 plus 9/4 pi. Again, it's 7 minus the area from -2 to 5. So minus the area. So when I'm going from -2 to 5, I'm going to have to subtract out. I'm going to have the 1/2 minus the 1/2 minus the 1/4 plus the 9/4 minus the 9/4 over pi. And that is all to be subtracted from the. Okay, so going on to our next page, our next question is we're going to look at B, which says evaluate the integral from 3 to 5 of 2 times f prime at x plus 4 dx. So I'm going to separate this into two integrals. So I'm going to take out the 2, which is a constant multiplier, the integral from 3 to 5 of f prime at x dx plus the integral from 3 to 5 of 4 dx. And I'm going to be using the diagram. So when I look back at the picture in part 1, I'm going to look at from 3 to 5, I am going to have a rectangle that is 2 across and 4 deep. So it's going to be from 3 to 5 is 2, and the height is 4. So the area under this curve is going to be 8 when I integrate. I don't actually need to integrate the 4x and put in the 5 and minus the 3. I know that this is the area under the curve. This is a horizontal line 4. And so here y equals 4. I'm going from 3 to 5. So I'm going to have this rectangle. So it would be an area of 8. Now, looking at the first one here, if I integrate this, I'm going to have 2 times the function f of x from 3 to 5. And I can go back to the diagram, and that's going to be 2 times f at 5 minus f at 3. And so going back to the graph, I'm going to go f at 5 is 0, and f at 3, they give us as 3 minus the square root of 5. So going back to where I was working here, I have 2 times f at 5, which is 0, minus f at 3, which is 3 minus the square root of 5. And then I have my plus 8. So simplifying that, I'm at 2 plus 2 square root of 5. So evaluate the integral. My integral is going to evaluate to be 2 plus 2 square root of 5. Continuing on to the next page, we are going to go to problem letter C. And letter C says we want to find, given the function g of x equals the integral from -2 to x of f at t dt. And our task is to find the absolute max. We know that an absolute max or min occurs at 2 possible points. Either occurs at an endpoint or at a critical number. So we want to find the critical numbers, and the critical numbers occur when the derivative equals 0. So we're going to take the derivative of g of x, which is equal to, using the second fundamental theorem of calculus, when the upper boundary is a variable and the lower boundary is constant, and we want to find the derivative of the integral, we can substitute that in. So we're going to have f of x times the derivative of x, which is 1, and then the constant disappears. So the derivative of g of x is f of x by the second fundamental theorem of calculus. So now we want to know, and it's important that you write this out. You're going to establish the relationship between g of x and f of x. So now we want to know when f of x equals 0. we're going to go back to the chart in problem number 1, and f of x equals 0 when x equals -1, when x equals 1/2, and when x equals 5. So with that information, now can look for the absolute max or min. So I'm going to take my x coordinates, and I'm going to take my endpoint, which is -2, and my critical numbers, -1, 1/2, and my endpoint, which is 5. Again, it says the integral here. You want to always include the endpoints when looking for absolute max and mins. I have the integral from -2 to -2 of f at t dt. And because I'm not moving from -2 to -2, the integral is 0. Again, putting the number back in the function up here. So my next one, I'm going to do the 1. So I have the integral from -2 to -1 of f at t dt, and adding that from my chart before, I'm going to get 1/2, and now putting in the 1/2, so the integral from -2 to 1/2 of f at t dt, and that's going to be -1/4. Again, always going back up here, and my last one, I'm going to have the integral from -2 to 5 of f at t dt, which is 11 minus 9 over 4 pi. Because I'm looking for an absolute max, the absolute max is going to be the highest value. So my absolute max, the absolute max is 11 minus 9 over 4 pi on the interval. Always include the interval from -2 less than or equal to x less than or equal to 5. And this is the absolute max, and maybe is 4g of x. Identify the function you're referring to. And that is how you do part C. We're ready to move on. The next piece is the last of this problem, part D. And we're looking for the limit as x approaches 1 of 10 to the x minus 3 f prime at x, f of x minus arctangent of x. So I'm going to say that that is equal to, and I'm going to put in the 1 for x. So I have 10 to the first minus 3 f prime at 1 over 1 minus, and again, that is f at 1 minus arctangent of 1. So 10 to the first is 10 minus 3. I'm going to hold off on the f prime at 1 and the f of x at 1, and I'm going to go down to the arctangent of 1. So what on the unit circle has a tangent of 1? Root 2 over 2, root 2 over 2 makes 1. And remember, inverse tangent is limited to quadrants 1 and 4. So I'm going to use the arctangent of 1. It's going to be pi over 4. Okay, now I need 3 times f prime at 1, looking at specifically this piece right here. So I am going to go back to the original diagram, and here is 1. I want f prime at 1. Well, f prime is the slope of the tangent line. So I'm looking at the slope of that line, and it is over 1 up 2. So the slope of the tangent line is 2. So f prime at 1 is going to be 2, because again, that's the slope of the tangent line at 1, and that's 2. Then the other piece I'm going to work on is going to be this piece right here, f at 1. And so all I need to do is find out the value of the function f at 1. And the function, the ordered pair is clearly 1. So I'm going to replace that with 1. And now I've got 4 over 1 minus pi over 4. And I would never leave an improper fraction. So that would be 4 over 4 minus pi over 4. And then invert and multiply, I would have 16 over 4 minus pi.